In this video I'm looking at the section A, so the multiple choice section for the paper 1 2017 periodic table elements and physical chemistry. So the way I'll do it is when we see the question on the screen I'll go quiet for a couple of seconds. If you want to pause the video, have a go at the question, and then I'll talk through which one's the right answer. So here's the first question. So obviously for it to be an isotope of iodine it's got to have 53 protons. So the first thing we need to do is work out the number of protons, so mass number minus neutron number, and we get 53 for A, 53 for B, 53 for C. So they're all isotopes of iodine. So D is 52, so the answer was D, that's not the isotope. Number 2. So the question's all about complex ions. So the ligands are attached to the central transition metal ion via either coordinate or dative covalent bonds. So they've given us dative covalent as an option, so the answer was D. So number 3. So the first thing we need to do is populate the oxidation numbers that we do know. So potassium has a fixed oxidation number of +1, it's in group 1. So 2 of them, so +2 from your potassiums. Oxygen, -2, times 4 is -8. So we need to leave no charge overall because it's not an ion, so it's got to be +6. So the answer was C. Number 4. So this question's testing your knowledge of basic chemical formulae. So the first thing we'll do is write down the formulae of A through to D. So calcium carbonate, CaCO3, CaNO3 twice for calcium nitrate, calcium hydroxide CaOH twice, and calcium sulfate CaSO4. And the percentage by mass is going to be the MR of calcium in the compound divided by the total MR of the compound. So we get 40.1% for A, 24.4% for B, 54.1% for C, and 29.4% for D. So the greatest is C, so the answer is C. Number 5. So this one's testing your knowledge of acid-base reactions. So there's the reaction for calcium oxide with hydrochloric acid, and you can see we've got a 1:2 ratio between the oxide and the acid. So we're told the moles of calcium oxide is 0.02, so therefore we're going to need 0.04 moles of the acid. We know its concentration, so volume is moles over concentration, but we're in decimeters cubed, and so we need to change that into centimeters cubed by multiplying by 1000, and so the answer is B. Number 6. So for every atom that's turned into a 1+ ion, 1 electron needs to be removed. So for a mole of atoms, 1 mole of electrons will be removed. So we need to know how many moles of neon we've got in that many grams. So mass over MR, 0.001 moles of neon. So that's how many electrons are going to be removed, how many moles of electrons. And then if we multiply that by Avogadro's number, we can find out how many electrons actually in total. And that comes out at 6.02 times 10 to the 20. So it was C. Number 7. So we're given the mass of silicon chloride and we're told it's reacting with an excess of zinc. So the moles of silicon chloride reacted mass over MR. So therefore the moles of silicon produced is going to be, factoring in the percentage yield of 90%, it's going to be 90% of those moles, and that's that many. So the mass of silicon produced is going to be those moles times the MR, 1.26 grams, so it was A. Number 8. So this one's testing your knowledge of qualitative tests. So the first one wouldn't give you a precipitate, that's the test for the ammonium ion, no precipitate. The next one is going to give you a cream precipitate of silver bromide. The next one is going to give you a brown precipitate of iron 3 hydroxide. So still no white precipitate. D does give a white precipitate of barium sulfate. So the answer was D. Number 9. First thing we'll do is rule 2 out straight away because bond enthalpies are always positive. So A and B can't be right. So the calculation is based around the enthalpy change being equal to the bonds broken minus the bonds formed, or in minus out I would call it. So the calculation looks like that. So the minus 9 delta H equals the sum of the bonds broken minus the two bonds that are going to be formed. We don't know that, we've got to work that out. And then solve for 2x and we get 298. So the answer was C. So number 10 now. First thing to say, in a concentration time graph, the concentration's on the y-axis and the time is on the x-axis. Zero order is when, if you change the concentration, there is no effect on the rate. Well, in graph C, the concentration isn't changing at all. You can see it's flatlining across there, so C can't be an option. Then we need to realise that concentration time graphs, the gradient is equal to the rate, and you can see that in B and D, the gradient is changing. So the answer was A, straight lines have a constant gradient. Number 11. So in this one we need to stress that excess aqueous sodium hydroxide is used, and we need to have an awareness of the fact that only chromium 3 plus ions are affected by excess aqueous sodium hydroxide. All the others just going to give you the precipitate, so we're not going to be left with CrOH 3 times, so we can rule that one out straight away. All 6 water molecules are involved, and so the answer is A. Number 12. So the first thing we need to realise is these are monobasic acids, so 1 mole of acid will give us 1 mole of H plus ions. So if we work out the moles of HA, so that's concentration times volume, 0.15, moles of HB, 0.135, its concentration times its volume, and so the total moles of H plus ions is just going to be the sum of those two moles. So that's 0.285, but it's in 70 centimeters cubed, so we need to turn that into a concentration, moles over volume, and so it's 4.07, so the answer was C. Number 13. So the sum of the partial pressures is equal to the total pressure, and partial pressure is calculated by mole fraction multiplied by total pressure. So if we work out the partial pressure from the nitrogen, because we know it's mole fraction, so that comes out at 0.994 atmospheres. The total pressure minus the partial pressure of the nitrogen is going to give us the partial pressure for oxygen, and so that's 0.426, so the answer was B. Nearly there. Number 14. So some basics. The E cell, the voltage of the cell or cell potential, is most positive minus least positive, and in terms of what the half cells, which way they're going to react, the most positive one will move left to right or in the forwards direction. The least positive one goes in the reverse direction. So the cell potential comes out at 0.46 volts. So statement 1 is incorrect. The reaction at the copper electrode, that's the least positive electrode, is going to be reverse. So it's going to be copper going to copper 2 plus and 2 electrons. So statement 2 is correct. And the silver half cell equation is going to move forwards, left to right. So you're going to generate silver atoms. So yeah, that is going to increase in mass. So 2 and 3 are both correct. So the answer was C. And finally, number 15. So I always say to my students, copper and chromium are weird because they have that 4s1 configuration rather than 4s2 like all the others. So therefore, statements 1 and 2 are correct. And when transition elements form ions, it's the 4s electrons that are lost before 3d. So the iron atom is argon 3d6 4s2. So that means the Fe2 plus ion is going to lose those 4s2 electrons, is argon 3d6. So statement 3 is wrong, it's incorrect. So therefore the answer was B. Only 1 and 2 are correct.